Now this is the lecture number 6, right? We have seen 5 lectures. Whenever I start, you might have seen, I give a little summary of the previous because I want you to be in that mood, what you have learned. It is important for you. That's why when I complete one lecture, you write few words what you learned. Is it? It is not necessary to by heart. You can write. That way you will understand what you have studied, where we are going. Is it? That is why for anything, how you plan as a whole, then part by part you will complete. That is how we should do. In the construction side, you see, if you start doing the things as you go, it will become a ribbon development. Is it? That is why you should know what you want to plan as a whole, then part by part. In survey, you work from whole to part, not part to whole. Is it? If you work from part to whole, what happens? You will get error, right? If it is 100 acres of land, first you will say outside 100 acres, then you will go part. If you say that this area is 10 acre, 15, 3, 3.5, then you will go either you will not adjust to the 100 at all. So that is how it is. So I want you to write a half page for yourself what you learn. Right? What that is important. So then what you are going to learn, you will see here how it is reconnected. Is it? That is how I wanted to uh, tell you what is this whole program is. I have told you what are the different component in the system. There is a treatment system we studied, then we studied the sewer system, the collection system, then the biosolids, water quality, effect on soil, effect on human health, right? Then the regulations which manages different layers of regulation, I mean level of working, federal, state, local, public participation. You work with a different group of people, consultants, regulations, industry, public participation. See how many components you are working with together. So that is how I have this course has been built like that. Whole. Then part by part we are going. So that you will have a complete understanding what you have studied, how it is done in all direction, right? So that is the intent of that. So earlier I used to mention about the biological treatment. So that is what we are studying. Uh, See fundamentals of biological treatment process and its important, right? Outline. I have given you the glossary terms. Please read them. That it is in the soft form. Uh, I wanted to give you hard copies, so we have to save some trees also. But if you read, that is useful. It should not just remain in your computer, right? So those are the terms in the field of wastewater treatment, in the field of environment. You should know what it means. If I say BOD, you should understand what it is. That is the fundamentals, right? That is why I am saying BOD, but sometimes I explain. But there are other terms, several terms also there. Is it? There are daily discharge, they are monitoring what is pH, what is nitrate, what is nitrogen, right? What is ammonia, what are the limits, what do you mean by limit, what do you mean by a wastewater treatment plant, what are the pollutant of concern, everything is there. There may be some more, but the major one, why what we do is we read that. That is already there. So we activated sludge process, carbonaceous VOD, right? Removal, nitrification, TS removal, activated sludge data requirement, regulatory data, process control data, common operator error, right? So operators are very important, people who manage that system. That is why they have to be certified. Just by experience, they are doing some of the things for many years, they want to do this. You need an upgradation, people who are working in this system. They should learn new things, right? They should, if you have to update yourself, it is going so fast, right? Earlier, if you just go back 10, 15 years, nothing was there, right? Things have changed in the field of computer, is it? But you have to learn, you have to move forward, you have to understand, because you have to work with advanced technology, right? In order to make it more efficient. So that is why it is important to understand the components which are required, tools, resources are required to manage the water quality, safe environment, right? So common operator errors, what they happens if they are not trained, what will happen? You know the consequences. You have to do it rightly, correctly. You should have a manual available on the site. Operator, he will work for 8 hours and go away. New operators come in, he will see the manual. New person will see the manual. If something happens, they're all in the emergency, what he will do? If spill occurs, what he will do? All it is mentioned in the manual. That is why when the treatment plant is built, we ask for an operator manual, operation and maintenance manual. You screen everything and approve, right? So that should be available. Some of the things, some of the documents must be available on the site all the time, correct? So that is what it is. Reduce aeration, save energy. How the oxygen supply is done? It is through the aerators. What is the biochemical treatment, right? If you say BOD, 5 days means what? If I say BOD of 1 liter, what you will see? 100 mg per liter, what it means? You should all know about this. Very fundamental. If you ask what is that? If you have to see whom you are addressing. The audience are also important. The people who doesn't know, if you are talking about the terms, they will not understand it. So that is why you should see the type of audience. Then you have to prepare your brief or anything so that they should be able to understand. If I say nitrate, nitrite, nitrogen, you should have an understanding. That is all given there. So that's why I gave you the glossary to understand thoroughly. That's it. So how treatment is done, in the sense what happens? Supply oxygen through the aerators. That energy is important. If you are operating number, you will design the treatment plant, oxidation plant with the aerators are there, oxygen supply is there. How much oxygen is required, which is related to the BOD. That is the design parameter, right? If it is inadequate, what happens? Your BOD will not reduce, right? When you design any treatment plant, what happens? It should be efficient today and it should be efficient after 30 years. Flow will change, cities will grow. You cannot design a system which is required today, right? And of course, there are sudden change in the population. City grows suddenly in some areas. Lot of big industries come in, then city explodes. That time you have an additional treatment plant, or you can update. When you update your all manual, every system will change. So that all you should have an understanding in that. Reduce aeration, reduce nutrient discharge. See, once you know how much is aeration required, that is all the design factor. They will design in the beginning, but you should see that that is implemented, that is working on the field. Working on the field is important. It is not like that the design and working on the field are two different things. People say, oh, it is in the paper. It is there is a base, there is a link. Efficiency you design maybe 95, here it is 9. But you can tune. Any design is, you need a little tuning when it is implemented on the site. Is it? Many I have heard many engineers saying that, oh, theory is different. This is not different. This is same. What is to be implemented on the field is same in the design, but still you need a tuning because there are number of parameters. In the design, you will assume certain parameters, but not exactly the same. It may be a little variation. That is why you will have to make sure that the things are working on the field. It needs a little tone. That is why don't have a belief in that this is different and this is different and just you want to just go away, walk away from that. No, it will work. So that is why you should make sure that these things are working on the. If you know this, you can save energy. Energy is a very important. Lot of energy is required in the treatment plants. If it is a active test, we will come across a different type of biological tests, treatments, systems. We use a lot of energy in the treatment system. So I will go a little bit quickly about this glossaries which are commonly used in the treatment system, in the biological testing. Why biological treatment systems are more famous today also? Because it is done by a bacteria, microorganisms, right? Microorganisms are do a very great job for the people. So they convert the unstable organic compound into a stable organic compound. Oh, water and carbon dioxide converted into water and carbon dioxide. Reduce the organic loading, right? So they do important job. So in that case, you should know what is organic matter, how much is reduced, what is aerobic treatment, what is anaerobic treatment. I have given in the glossary. You can also, I just wanted to brief a little bit about that. Quantity of oxygen required by microbes in the oxidation of organic matter under aerobic condition. Aerobic condition in the sense in the presence of oxygen, anaerobic in absence of oxygen. What is the difference? Detention times are different. Oxygen supply. There are bacteria which are more efficient in aerobic condition. There are bacteria where who can work in a absence of oxygen also. That is what your digesters are. Right? So then suspended solids. Solids in the suspension larger than about 1.2 micron in size that can be removed by the laboratory filtration techniques. Right? So if you are telling to someone BOD is this, suspended solids are this way, so how you will define for a third person? So that is why you should have an understanding for yourself when you are making a statement. Then biomass, living biological matters. I will go a little quick on that. So activated sludge process, a biological wastewater treatment process in which a mixture of wastewater and activated sludge. Why it is called active? Because what you do in the activated sludge, we will go further, you will understand much better. Well, when the sludge is there, 2%, 3% of the sludge, 10% of the sludge is again recycled. You want to keep it active sludge. That is why it is activated sludge process. Because what happens in the aeration tank, organic matter is converted into stable compounds. And in the next clarifier, these bacteria are removed as a suspended solids. Then part of that you recirculate to the oxidation, to the system. because they are removed as a suspended. See how important work they do in a fraction of a second, right? So, activated sludge is aerated in the reactor basin in aeration tank. Biomass is settled in the final clarifier with the most biomass returned to the aeration tank, while some biomass is wasted. Some is wasted, some is right. That is why the sludge which is coming from the secondary treatment, you send it to the thickeners, right? In the first in the grit chamber, the waste produced, I mean the grit produced, you send it to the landfilling because they are solids. This still consists of bacteria and a moisture. It goes to the thickeners, then it goes to the drying beds. Then return activated sludge, settled activated sludge that is returned to mix with the raw or primary settled waste, right? Then waste activated sludge, the quantity of microbial solids that has to be wasted from the system at the rate it is produced, same as the excess biomass. Okay. So we are entering into the treatment system. I'm giving some basic understanding about the terms frequently used in the system. Sludge age, the average time of the day's microbial cell remains in an activated sludge, same as mean residence time and solid retention time, right? Bacteria also has an age, right? So that is why you need a recirculation. Mixed liquor, a mixture of wastewater and activated sludge undergoing aeration in the reactor basin, reaction tank in activated sludge process. MLSS, mixed liquor suspended solids, the suspended solids concentration in the mixed liquor. Okay. Settleability, how well the biomass settles, compact, clears the final. That is important. It has to be settled. That is why you give a sufficient retention time so that they can get it. Right? Nitrification, biological conversion of ammonia nitrogen to nitrite by nitrifying bacteria. Is it? Nitrite is unstable. It is converted into nitrate. Reaction is done. If I say that there is no organic compound, means what? The reaction starts as soon as the wastewater comes out of your residence because it has a bacteria. When all the organic matter is converted into water and carbon dioxide, reaction starts. That's why when you go near the wastewater treatment plant, it starts, it has some odor. You feel that. That's why people working in the field of wastewater, see, cleaning the waste which is produced, they are great people, right? All the time they are there taking care of the stuff which is produced, right? They are very important component of our whole system, right? They do a great job. It is very easy to work on the table, work nicely and go home. Like people, you see, this waste is treated and make it compatible, then discharge. That's why you see who are the stakeholders, how many people are involved in order to make the whole treatment system good environment. If it is good, everybody feels happy, right? But you have to work towards when somebody shows the pictures in other places, so it's so nice how they nicely they are maintained. Some people have worked for that, right? People who are there, they have worked for that. The same should be like here. When everything is good, people like. Construction also, a lot of people work and make a good, big, nice house, and they go away. They will forget. The people who are responsible of making is important, right? We should always have a gratitude to them. Right? That is what. So, nitrification, denitrification in the sense biological conversion from nitrate to nitrogen gas. What happens? The reverse atmosphere takes. Nitrification, denitrification go hand in hand. And nitrate is converted into nitrite is, and then the nitrogen gas, right, goes out of the system. Anoxic condition, there is a condition exists between aerobic and anaerobic. That is why we want to make sure that the wastewater is always in a continuous motion. Otherwise, what happens? We want to create an aerobic situation. If its sludge settles all the time down, it creates an anaerobic condition. That's why we want to make sure that aerobic system is working. Right? So anoxic condition is in the sense in between. Why there are three conditions now here? Aerobic, anoxic, and anaerobic. Different bacteria exist in that conditions. Right? So that is what. How we will do that? You can find out what kind of bacteria are available. Right? You might have heard heterogeneous bacteria, filamentous bacteria, fungi, many bacteria. Different conditions, situation, different bacteria, different capacity. So, anaerobic conditions when the mixed liquor has no oxygen. There is also a provision. If oxygen is not there, still you can treat. If it is a high organic content, what we do? We do in an anaerobic situation, reduce lot of BOD, then we put to aerobic conditions and different ways, combination, designs, depending upon the type of wastewater it is. That's why I was telling you, it depends. What are the influent concentration? Accordingly, we will design. Domestic wastewater has an BOD around 300, 400, 500. If you take a ratio, F by M means what? Food to microorganism ratio is 0.5. We say it is degradable. 0.6, 0.7, it will difficult. Right? That is how. Industrial wastewater, less BOD. Pollutants of concern. That is why we are worried. That's what we do. We mix certain industrial wastewater into domestic wastewater, make it compatible. It can take some, right? That is how the system is designed. So, in a different conditions, accordingly designed. Facultative heterotrophs, bacteria that use organic matter as their carbon source, can thrive in the aerobic, anoxic, and anaerobic mode, right? Different. Endogenous respiration, the continuous process whereby bacteria oxidize their cell mass to produce energy. Right? What it does, two-thirds energy is used to convert organic matters into a stable compound. One-third, approximately, one-third is used for their production. Bacteria, number of bacteria will go on increasing, right? That is how your food to microorganisms ratio. When the food is reduced, number of microorganisms are more. What will happen if the food is not available? Microorganisms deterioration takes place. They are removed in the next treatment system as a suspended salt. See how phenomenal it is. They do a tremendous job in removing the waste which is produced, and the next stage they are removed as a suspenders and disposed of. So that is why bacteria play very important role, right? They do a toxic, reduce the toxic substance in a fraction of second, and then they are removed from the system. Then again, new bacteria will come and take over. So this is how it is. Types of biological treatment, activated sludge process, still it is popular, right? An aerobic process that uses a high level of oxygen, nutrients to treat sewage, trickling filter, aerobic process that uses a bed of rock to break down organic matters. This is called attached growth. There is a media, wastewater goes into that, there is a thin layer, then the organic matter is converted to a stable compound, attached growth. So attached growth media is there and wastewater is passed through. Activated sludge process, it is slightly different. There is a tank where the aerators are fixed, and you have seen the activated sludge process yesterday, correct? You also seen the aerobic treatment yesterday. I have shown some videos, right? And in earlier visit and today's visit also, you will see some of the biological treatment systems, how they are, right? And you have seen how the wastewater in the beginning and how the effluent is. See, you were able to do that if you do the things correctly. You will. That's why you should measure at each stage. Each unit is working properly, and the end product is the phenomenal waste. I mean, the effluent comes in, and then accordingly you can use it. You can recycle, right? So, rotating biological contactor, a system that can be used as a secondary tertiary treatment process to remove BOD5 and nitrifying wastewater. You can see many papers of mine on this. We have worked on biological treatment systems and also oxygen transfer, how the oxygen transfer takes place in the wastewater treatment, biological treatment, prototyping design, and see, make sure that designed system works there. Whatever the oxygen is needed for the biological system is able to produce by the equipments you have used, right? That was where there is a mathematical model which had, proposal, I mean, is there in the system, and which is more efficient. By that you can design the system. Oxygen transfer in the rotating biological contactor, and see many papers are there for it, right? So tertiary treatment and advanced treatment process that remove the suspended solids, the dissolved substances from the wastewater after primary secondary treatment, right? See, that is important. You should make sure that all there is no pass through. If the pass through is there, it will cause a problem, right? So different biological treatment process. See here, this is how the system works here. Preliminary treatment, primary clarifier, secondary treatment, aeration tank, secondary clarifier, nutrient removal and disinfection, and final effluent. Disinfection is also needed sometimes. You can also, you saw there, I think in the visit they gave an ultraviolet treatment, right? Disinfection. Or you can use also, why? When you are discharging it to the river, we try to avoid dechlorination. Today, ultraviolet is the best method for if you are discharging it to the river and stream. If there is a residual chlorine is high in content, it may affect the fish growth and fish ability, you know, fish movements. That's why we want to make sure that when you use chlorine as a disinfectant, in case of water supply, we use chlorine as a disinfectant. Why we use Chlorine as a disinfectant in drinking water. What happens? You treat the water at some place, then you put that water into a distribution system. Before it reaches consumer, it should not get contaminated. That's why we keep a residual chlorine about zero point 0.5 mg per liter or zero point 0.2 to 0.5 mg per liter, so that before it reaches the consumer, if there is any contaminant in the system, that is taken care of. There we use. But if your source of wastewater treatment discharging it to the river, you don't want to use disinfectant. I mean the chlorine as a disinfectant. Ultraviolet is the earlier, it is well developed now. In many systems I have seen, they have converted the use of disinfectant to ultraviolets. Technology is expensive in the beginning. As we move forward, it becomes less expensive, more efficient, because when you are discharging it to the rivers and streams, you want to make sure that the chlorine should not affect the fish population in the rivers and streams. That's why we use something. See the overall system. Wastewater treatment system enters, preliminary treatment, you will remove suspended solids, grade or floating, everything, which is whatever you oil and grease treatment in the beginning. Is it? Many people just throw oil and grease in the sewer systems. That all may cause a problem. If you carry oil and grease, if you are not designing the wastewater treatment system without the oil and grease trap, after grid chamber or before that, what happens? You are carrying that oil and grease continuously unto the end. Your treatment efficiency reduces. See how important it is. So all this component work together. That is was I was mentioning in the earlier lectures about the fog programs. You should make sure how many restaurants have this facility here. Is it? You go to restaurants. No? So how many restaurants have a grease trap before they discharge? Right? What will happen? Who will take care of that? So those things are important. Different component which contributing the hindrance issues has to be fixed. That's why you see what are the different components in the whole ecosystem. If you work all the system is built like this. You have, that is why each stakeholder, each component has to work efficiently in order to make it successful. Right? That is why in the beginning I was telling that I want you to write lecture 1 what you understood, lecture 2 what you studied, 3 just half page. Right? Then you will understand how the flow went from right from the beginning to the until end, to the success story. I also give some tutorials how this is implemented on the site. That's a big difference. They are not small industry, they are very big industry. Well mechanized, 1,000 people working, millions of dollars. If you work and reduce the pollutant at the source, that is possible. The same thing should happen. When you go out same with the same mission, same mindset, you should have. Right? Wherever possible, try to implement them. Wherever, whatever job you are, do that right. Spread the right things. So you can see the different components of the treatment system. Primary clarifier, aeration tank, so aerators, secondary clarifier, nutrient removal, disinfection, final effluent and sludge is collected in the digester and that is sent to. So we want to remove the gases also. Collect the methane and the sludge is sent to the thickener where we remove water and the sludge is then disposed off to the dry beds, or it can be used as a manure if it doesn't have any pollutant of concerns, metals, right? So you can see the aerators, how the aerators are there. I have taken some pictures of the built. That is how you design. What is the volume of the wastewater in the tank and how much is the oxygen required? So that is a good balance. You should be able to understand in order to have it. They are not randomly fixed somewhere, right? So you should make sure that each corner, the wastewater, bacteria all get the right oxygen in order to reduce the organic compounds present in the water, right? So these are the areas. So wastewater, see, you can see the pumps here all the time. You should have a standby. If that fails, you should have a standby. You don't have a choice there, right? Because wastewater is it's a continuous process. If if it fails, what happens? The system, whole system, you have to have a bypass sometime. Very purposes. That's why we have one set of standbys and another set of standbys. Then a biological reactor, clarifier, and then return of sludge. That's why it is called activated sludge process. Sludge. Return of activated sludge is recycled back to the biological. What we will learn today to identify, understand primary activated sludge process, goals to identify, understand primary data requirement needed to operate activated sludge process, recognize common operator errors, how to eliminate them, right? Reduce aeration to achieve energy and money saving. That is important. If you no need to put something extra in order to become efficient, if it is not useful. Because if you put a aerator continuously 24 hours, if you are putting even 10%, 50% more, what happens? It's a waste. Need a lot of energy. If you are putting under, what happens? Treatment won't take place. Untreated wastewater will. So that's why it should be appropriate. That is what is called in a design, right? So reduce aeration to decrease the nutrient loading, discharge to the receiving water. To understand the activated sludge process better. Activated sludge process, the carbonaceous removal, nitrification, TSS removal, maintain neutral pH. pH is very important. It is a very small and easy to maintain. But if you don't maintain it properly, it will cause a big problem in the biological system. You need you will have an online flow measurements today. You can monitor it well. You can have an online system where a person can see how the wastewater is in progress. Everything you can do. pH is also very important. But what happens if there is a variation in the pH? It will affect the bacterial growth. The very treatment will get upset. How we will find out you need an appropriate pH? You should have a measurements. That's why I say that first when I go for a visit and see whether you guys have calibrated your pH or not, instruments or not, right? If it is not calibrated, 10 may be 12 or 10 may be 8, right? So they are simple things. You should have mindset what to see, right? That is important. So minimize the quantity of solid produced to optimize the energy, denitrification and phosphorus removal. Phosphorus removal also you should see wastewater how much phosphorus is consist of. Then if you are just removing leaving the if the effluent consists of a phosphorus, what will happen? Growth, algae growth and all will start taking place there. So that is why it is important to maintain the phosphorus removal also. Successfully activated sludge process performance is judged by the effluent quality. How we will judge whether the treatment is working? You will see the effluent quality all the time. Measure them and then use it for other purpose. If you are not measuring it properly, if you are discharging or using it for other purpose, you are creating another issue. First, you are not doing this is right, and you are giving rise to another issue. Right? Achieve an excellent effluent quality while achieving our process goal, minimize energy use using plant equipment efficiently. See, you should save energy, you should have a effluent quality, then efficient equipments. They are important. If you are using any equipment which is a old one taking large energy, you don't want to first understand what is required. I think I remembered worked in one of the project where for cooling towers, where the earlier, long back story now, they are using a seawater as a cooling tower water to reduce the temperature, because water is very important. In the cities, big cities, you bring a water like this in the bottle, but if it is in a refinery, they use a lot of water. I think leather industry also uses a lot of water, correct? Somebody was working, and mining uses a lot of water for the process plants, cleaning. So you don't get a water. So what they can do? They were using a seawater. See, if they are using a seawater, it's a once through system. Temperature is to it has a high temperature. When you passing the seawater through that, what happens? Concentration increases. Then you cannot recycle. So just discharge it to the sea again. See, you can do anything people are doing. Where there is no resistance, anybody can throw anything. That is what this is. So later what happened? They have an understanding. They said municipality produces a lot of sewage. So what they did is they brought all the sewage to their industry. That municipality was very happy. Somebody is taking the sewage. So they were ready to give a sewage. They made all the initial work. They brought sewage. Sewage is produced. People are not ready to take care of that, right? If somebody is taking care, they are happy. So did that. That the I think group was working on that. So brought the sewage from the municipal to their industry and they treated the sewage. It is good win-win situation. So they treated the sewage. Then treated effluent quality was such a nice. They were using the same water as a cooling water 17 times, and then they were discharging. See how much volume of the water is reduced. You did a great job of bringing the sewage, treating it, and using it for your purpose. And what is the big reduction? Once through system, you have to pull lot of water, energy, lot of energy to bringing that, water to your cooling system and passing one, it is a one tooth system, 17 times more than the water required. You are taking the seawater. Now it is 17 times less energy. Started saving a lot of money in the energy itself, and also the municipality was happy, right? So this is how you can see the different ways of using the technology and how it can be done, right? So both are happy. So this is possible. So these refineries and all use a lot of water for their as a cooling tower. Conventional activated sludge process are primarily designed to remove CBOD, means carbonaceous BOD and TSS from the waste. Organic loading entering the activated sludge channeled into two directions, growth reaction and energy. Right? Growth reaction, organic nutrients, biomass, new cells are produced. By the growth reaction, biomass is produced as a result of consumption of organic matter. That is what I said. So bacteria, they use some energy for their production, and also they do a great job for the humankind. So they will reduce the organic matter to a stable compounds, carbon dioxide and fluoride. Right? Sludge production, solids produced per day, solid retention time. Organics, oxygen, carbon dioxide and water and energy. Right? Oxidation of organic matter in the wastewater is accomplished biologically using variety of microorganisms. Primary bacteria, the oxidation reaction produces energy for the bacteria. We use a heterogeneous bacteria. They are very efficient in treating the wastewater. But if there are pollutants, what we will do? So we try to acclimatize these bacteria to remove the specific compounds if it is a toxic. Even like cyanide, certain industry, fuel industry, refineries. See, we are very happy if the gas prices goes up, gas price comes down, we are very happy. Right? But they also produce contaminant like cyanides. So there are bacteria which reduces that also. That we try to acclimatize people who are working in a biological treatment plants. They know. How you do? There are a group of heterogeneous bacteria. Have done that. So that's why I'm telling you. People are very heavy, right? They don't leave even bacteria. So bacteria, organic matter, if they are reducing heterogeneous bacteria, what we will do? We will put 1 gram initially the toxicants and 2 gram, this will reduce 2 gram here, 2 gram here, 2 milligram here, 3 milligram up, 3 milligram down. We train the bacteria, right? We acclimatize. We make sure that what happens, bacteria which are efficient in removing a specific pollutant, they are there. We make sure that they are there and then right? We're able to remove cyanide up to 80 milligram per liter. So, but we go slightly different technology on that. When you are using a toxic, rotating biological conductors are very useful. In a active test sludge process, if it consists of any pollutants, what happens? If there is a dose is little higher, it will spoil the entire system. That's why we want to make, we use attached growth system. We want to pass the wastewater down. 3/4 of 1/4, 2/3 of the wastewater, submerging into it, and then we pass the wastewater. So bacteria is on the top. It will catch the pollutant and treat it. So this is so if it is a toxic, there are advantage, disadvantage of different technologies. In widely we use a activated sludge process because domestic wastewater, and if they are capable of treating it with the heterogeneous bacteria, nitrate, nitrogen bacteria are also present. If it is consist of nitrate, phosphorus, other organic compound, we use a activated sludge process. That is most common. You have seen that in many places. But we have to go to that extent also, remove specific compounds. Right? We should not be happy. We if you are not measuring it, no pollution. No measurement, no pollution. Everything is fine. That should not be there. But thorough analysis we do of the influent first, what is present. So accordingly you can design the system. Yesterday somebody asked me a question in the industry, why you chose the reverse osmosis process, right? So that is important. We see if the TDS is there, it's no point in putting a activated sludge process. This reverse osmosis process is more efficient in reducing the TDS, dissolved solid. Even you will not understand how much is the dissolved there. It looks good because it looks like the treated effluent, but it has a dissolved solids, right? So that's why we go for that. That's the pre-treat. Then we discharge. It has a BOD. It may not be more efficient in removing the BOD, but it removes the TDS, which is the main concern. Then BOD, which is remaining BOD, it will be discharged to the receiving treatment plant, and that is taken care of. This is what this portion industrial side is a pre-treatment, and there it is treated. So this is how we take the advantage of this treatment technology. So oxygen requirement, I said oxygen requirement is very important. You should make sure that the right amount of oxygen is available for the bacteria to reduce organic compounds. Then there are some numericals about nitrification, and yesterday you saw one video how that takes. I will go a little faster here. So you have seen how the nitrification, denitrification, they go hand in hand simultaneously. What happens? Ammonia converted into nitrite, then nitrate. Nitrate in the denitrification process. What happens? Nitrate is converted into ammonia. That is how it is treated. During nitrification, alkalinity is needed to buffer up the pH. Alkalinity in the sense you need a higher pH, right? Any questions on that? So what you learned is in the biological system, what it consists of, what are the terms and conditions, right? How the wastewater enters the treatment system, right? And how you are taking care of the general domestic wastewater. It may be a BOD, may be higher, lower, doesn't matter. That is what we do is in the pre-treatment world, we use the industrial wastewater, right? The industrial wastewater produced has a low BOD. So we take the advantage of that, right? If you see here, little back, in the nitrification, we do the denitrification. That is how we do. In case of the activated sludge process also, what we do, industrial wastewater has a less BOD and domestic wastewater has a BOD. So we want to mix them, take the advantage of. But that is why in the pre-treatment world we tell the industry the pollutant of concern must be removed. If they are producing a toxic, if it is a categorical industry, what happens? They just can't discharge everything and mix it with the domestic wastewater. No. That is what our system is. We will treat partially. You pay whatever the amount you are discharging accordingly. That is how the agreement. Different industries, you can't take all the wastewater mix with the domestic and treat. You analyze. They are called a tributary industries. When they are discharging, what we do is make sure that if it is a metal industry, toxic substance can be removed. If it is a food industry, it has a lot of suspended solids. You just can't discharge. You have seen the example of the case studies, right? They produce a lot of suspended solids and high BOD. So what we do, they are discharging it to the domestic wastewater treatment plant only, city's waste treatment plant. It has a high BOD. If it is more than 1000 milligram, you just can't discharge. You cannot overload. If it has a suspended solids, it is suspended. Food processing industry have a lot of suspended solids and a high BOD also. So in that case, they say that reduce the suspended solids concentration to the level of 300, 200, then you discharge. So what they will do? They will build a big settling tank, series of tanks. It may be geomembrane, because if they are producing a high volume of wastewater, you cannot ask them to have a concrete tanks. If it is a volume is less, it is fine. That is why what they do, big acres together, the geomembrane, double lined, it is a mandatory. If it is a industrial wastewater, it has to be double lined. So they do 2, 3, a big geomembraned I mean the ponds, they are connected each other, and then the suspended solids settle down, reduce to the certain range, and then they discharge. If it is a high BOD, I said they have a suspended solids, high concentration, high BOD also. So they put a DAP system. You have seen yesterday the DAP system there. They have a settling tank to remove the suspended solids, and also a DAP system where the oxygen is added so that the BOD is reduced to some extent. If it is 1000, you can reduce it to 800, 600, then we will discharge. We will take rest of that. So this is how the system works. That is how you have to see what kind of industries are there, right? Then accordingly you will have to design a pre-treatment system, then discharge. If there are certain places where the number of industries are more, you cannot ask all the industries to discharge, we will take it. You do a pre-treatment and then discharge. Sometimes it is a not possibility. That is why city sometimes what it does, it builds two different treatment plants. One is domestic wastewater treatment, that is the mandatory, that is called POTW, which is publicly owned. See, the name is publicly owned because people contribute. If anybody says the city sewage treatment plant means it is your own treatment plant, right? And nobody is taking care, right? That should not be there. And you do not know also. See, that is your own built by your money only. That's why the name they give. That public should understand it is ours. Sewage treatment plant means it is somebody. So that is important. That is yours. So what they do is, if the number of industries are more, then they build a separate one just specifically for industry. If 10 are there, we can put 7, 8 there and 2 here. That is how you should have an understanding. It depends upon the capacity. I have dealt with many industries there where industry goes on expanding. If your city treatment plant remains at the same level, what happens? There is a problem. So that is why the common effluent treatment plant concept came into existence. All small industries together, they build a common effluent treatment plant, then they discharge. And based on the volume and the concentration, there are some management experts are also here, they can work out based on the organic concentration and the flow, the cost of that is divided. So when they will run properly, because the stakeholders are there, you know, here public means the whole public, maybe millions of people there, half million is there, quarter million is there. Industry giants will come together and they build. So then they try to run it efficiently because they pay for that. They have to pay as per the concentration, as per the loading, the volume. So that is how this common effluent treatment concept comes. But the problem is, if they are in the industrial zone, they can have an efficient treatment. But if the industries are located at different places, suppose you have many small industries existing in the corner of the cities, who will account for them? So they will be discharging the wastewater to the sewer system, but still it is the responsibility of the city's treatment plant to treat. So that is why nowadays what is happening, they are trying to make an industrial zones in a particular area, try to shift the industries which are existing in the other area. If it is a big plant, they can have that capability. They can build their own treatment plant, and then they can also put a pipeline to discharge the wastewater to, depending upon the quality of the wastewater, to the creek or to the river, or they can do a land application. They have that much resource. So this is how they are trying to do it, but it takes time. Now the new cities and towns, they are built with the concept that there is an industrial zone and residential zone and the public place and the future expansion. This is how you have learned in the your engineering and your schools. It has to be there, but at least the new areas to be should be like that. So then it is easier to plan. And there are hospitals also, clinicals also. You have to make sure that the city has to make sure they are treating the waste coming out of that system, should be taken care of that. We have a program there for the cities. This time, okay, I have little 15 minutes time. So we have a program called the fog program, where all the restaurants and the local entities come in under the scanners to remove oil and grease and system. We have a dental program where the dental clinics, what they do, the amalgam which is coming out, that enters the sewer system also. They have to put an amalgam separator. We make sure that dental clinic has an amalgam separator. So there is a one-time authorization. They have to build and have an amalgam separator. The wastewater which is coming out, it should pass through that. It has a good efficiency. We are making sure, we are training the cities, make sure that all the dental clinics are coming under that stand. I monitor all that, and we see that our people monitor them. So they have an responsibility of reporting. They uh, what is it? Quantity is less. See, that is the important. Quantity is less, but if they are carcinogenic, what will happen? 1 ml, 2 ml in the clinic, oils and all they use, if they just leave it, what happens? They are carcinogenic. They will go through the sewer system. They will enter the treatment system, and you will not be able to remove, because your treatment System doesn't have a capability to remove. That is, tertiary treatment is not just the giving a chlorine dose and discharge. That's why you don't measure. No measurement, no pollution. So that enter the, you are discharging it to the river. What happens? That will enter the, yeah, people who are working in the fish feed somewhere there on the fisheries. I heard somebody was working in the fisheries. Yeah. Oh, yourself. See, they are the people mostly afraid of. See, their job is to protect aquatic life. That enters the food chain. See, I will come to some of the pollutants. You you can imagine what is the removal concentration. You see the metal concentration you have seen how much? It's not much, right? If you say zero point zero 0.01 milligram, 0.001 milligram is microgram, we will go microgram. Right? I'll see some of the standards you see, they are in μg, not mg. 1,000 times less, very less, but still they are there. We go parts per billion. These are some of the pollutants which are coming now. That's why we don't have a proper methodology. We are working. We have a guidance document. Come up and see. There are parts per billion. Yeah, parts per million. Parts per billion. See the PCB and PFAS. You see, they are all in the system. We try to track the sources already there. If it is a point source, industry is the point source, right? Industry is the point source you can locate. If it is a non-point source, if it is a storm water, if it is entering the environment and water quality river through the storm, non-point source, what you will do? It will all go to the river. If the clinical waste or any toxic waste just it is thrown outside, where it will end up? Carcinogenic, even 1 ml 2 ml. That's why any waste which is coming from uh, the clinics, it has to be incinerated, highly toxic remain. So it is not the question how much concentration. It is not like that everything should look big, but minor concentrations are very dangerous. So that is why in the fisheries, what happened? They enter the aquatic system.
Yes, from water, it is by the fishes through gills. They intake the water and which contain the chemicals, and in they get stored in the fish muscles. And then when the fishermen do the fishing, and they are used for human consumption, so it reaches human and they are carcinogenic.
This is how. This is how we enter the food chain. If you are just throwing on the soil, and many people on the here on the soil department, you see, enters the food chain through that also. So these are listen. So these are the some of the contaminants are carcinogenic. They you just can't get rid of. However small they enter the food chain. And in the body, you see the concentrations I had given for earlier. How small it is. It will all end up in the food chain, in the environment. So these are some of the things you will have to take care. However the small the concentration is, you understood the importance of biological system, what are the components in the biological systems, how you will have to take. I told little bit about how to remove the toxic compounds also, how we treat, how we acclimatize, and how we were able to target certain concentration, certain contaminants, pollutant of concern in order to make it safer. So This is about all the biological treatment systems. You have a basic understanding how this biological system works, what is important, how you should take care of the wastewater. All is contained in this lecture. If you have any questions, let me
Any question? Any query?
Thank you, sir, for your insights. Sir, I have one question.
know.
It's not exactly related to this, but I have one doubt in my mind. Like in India, every year temperature is increasing at very fast rate. Right now in April, we are facing around 40 degrees Celsius in many parts of country, and most of the wastewater treatment plants, mostly industrial plants, are located in the urban areas or areas which have quite high temperature. So is it going to affect the efficiency of the plants due to high temperature, like biological activity will be inhibited, or any this kind of thing we will face right now or in coming years if the temperature goes on increasing like this? And especially where these industrial treatment plants are located in our country are mostly the areas where the temperature is quite high due to urbanization and all. So I have a doubt, is it going to affect these treatments or biological activities which we look upon in the secondary treatments?
Very good. Sit down. Thank you. So, bacteria, there are a wide range of bacteria. In heterogeneous, if you see the bacterial range, there are thermophilic and mesophilic, right? They work at a different temperature. Thermophilic bacteria are even work at a higher temperature. So that is not going to affect. You have also seen there are countries where the temperature goes down. You can also see the treatment plants there. We have a biological system. Where I live, the temperature goes down. Where I lived earlier, temperature goes minus 40. So still we have a biological system. So we have a wide range of bacteria which can survive at different temperatures and take care of organic compounds, take care of the biological treatment, work efficiently in a different temperature zones. We are very smart in taking the advantage of bacteria, right? But we have to do at the same time our responsibility also. That is important. So that is not going to work. That is not going to affect anything. We have technologies. We have the bacteria range also which work at different temperature. Whether it range increases or decreases, we have um, a source for that, tools for that to make it more efficient. Right?
Sir, I have a question. In our cities, daily use waters, what we actually get from the water sources, they use chlorine, and that chlorine, after using the water, it is being the wastewater. So there is the concentration of chlorine in the wastewater also, in the effluent of the wastewater of the city. So what problem that can cause? And as we know, chlorine is a carcinogen. So
Okay. So not carcinogenic. So what happens is, listen. So in the wastewater, if the effluent is discharged to the river, what we do is we give a very small dose of chlorine, which will be very residual. Earlier we used to do, but now the ultraviolet technology has come. If you know the wastewater is effluent treated wastewater is discharged to the rivers, we use an disinfection, ultraviolet disinfection we use, so there is no chlorine at all. That is, earlier they used to happen, but still that is not a big problem. Many plants still use, the treatment plants use the chlorine. So you give us very small dose of chlorine just to make sure that the bacterial load should not be more at the time of discharge.
water sources, what the water supply of the city. The supply of the city is the water demand, what we use in our household.
Also, drinking water,
Yeah, that drinking water contains a
chlorine.
good concentration of
Ah.
chlorine, and that is going to the effluent of the wastewater after being used in the household. So how
No, no, no,
the
no.
activated
Correct.
sludge is
Okay, go ahead.
working?
Okay. So if you are using the drinking water, we try to keep the residual chlorine zero point 0.2, zero point 0.4, zero point 0.5 less than that, so that that is taken care of in the distribution system. But once it is done, it won't be having any chlorine. It is zero chlorine. The wastewater which is coming out of the residence doesn't have any chlorine. It won't be having chlorine at all. So that way it enters the system. But in the drinking water, I agree. Sometime if the chlorine dose is higher, you can immediately feel. In that water, you will have to wait for some time, so it will just goes away and then drink. So that is why it is important when you are putting the chlorine dose, residual chlorine, you will have to be very careful in measuring it. That's why measurement plays an important role. So you should if you put a more chlorine, residual chlorine, that may end up in the drinking water. You immediately, it gives us some kind of a pungent smell. You can notice the chlorine presence. So that is important. So dose is important. By that way, you can reduce it.
Sir, another thing is, what is the source of this activated sludge in a basic, after just setting of the STP. So, what is the primary source of the fast giving activated sludge?
Activated sludge is the biomass. We develop, bacteria are developed, and they are responsible for reducing organic compound into a stable one, right? So bacteria will go on increasing. Bacteria are there everywhere in the sludge. If you analyze that, it is not a big thing. So when we did, so we are treating wastewater from the refinery. We brought the waste sludge from the treatment plant, from the refinery, and then we started an experiment. Many people bring the sludge from the domestic wastewater sewage treatment plant and then develop into the system, and then the treatment, biomass is used for the treatment. So bacterial are there in the sludge. It's not a
Can we use any modified biomass for refining the oil and greases? Sometimes people use some biotechnologically modified organisms to remove the oils.
you can
Petroleum and all.
you
So.
can do that. There are the bacteria's kind of stuff is available. They use it and put in the water, and then they start doing it. So it is available in the market also. They start with that, right? In the septic tank, what you will do, when the septic tank is built, we bring a cow dung and put there. Bacteria are already there, right? So bacteria are developed initially, and they go on increasing, right? Then the septic system starts. So you can bring a sludge anywhere. The all that is why the heterogeneous bacteria are present. Number of thousand type of different bacteria will be there, and that will be acclimatized according to the type of wastewater. It is not that difficult. Anywhere you can find out.
Sir, actually, I have one question regarding the type of the biological treatment processes. So most of the times, activated sludge process is the most popular and used, and that is the very old technology also. But there are different other things also: membrane bioreactor, RBCs. You have said trickling filters. So industry decided its own what type of the technology they have to use, or there is some guidelines regarding the capacity of the wastewater or like the type of the pollutants.
So
Who
that is
decide that thing, sir? Actually,
correct. So there is no technology like you want to use the best technology. That is why when you do the design, you will find out what are the technologies available according 3 4 technology. You will make a comparison studies, and you will say that this is more efficient activity sludge processor, stabilization pond, oxidation ponds, right?
yes, sir.
And rotating biological process or trickling filter. You find out all these different methods which is useful, efficient, then you use.
Okay. Firstly, there is some
uh,
exercise regarding the energy and all these
Yes,
things.
yes. Energy is very important. That's why you see active sludge process
That
is
is,
the word one where it is easy to operate.
yes, sir.
Just sometime you have to swim against the stream and find out which is the good one, right?
Yes, sir.
So once the system is set, people are more comfortable in using that, right? So there are other technology, biological treatment technologies are there where we use different technologies to treat the waste. I will show you one more case studies what kind of biological system is used. Sometimes not today we are have a visit, probably tomorrow. We use BIDA system
Okay.
to treat the high organic compound and also PCB. That's one example I want to give it to you. I will show you. See what is the different technology. We went against these convention
Traditional. Yes.
technology, and that has worked very well,
Okay, sir.
right? So there are many technology. That is, the designer or engineer has to find out which technology is best, right?
Yes.
If
Yes.
it becomes old, they will change and put the new one. That has happened in many places. As we grow, we just move to one technology to other technology. See, if it is producing a high toxic content, if the then we go for the modern technology as we did. So that has happened. There is a process in the system also. They award the best technology used in the industry. So many people re-evaluate what they are using, whether it is efficient, and is there any technology available outside. That is why you go to conference, you go to technical shows, you can find out they demonstrate this is the best technology available right now. Earlier it was not there. The advantage, disadvantage. There is a gating process.
Yes.
I used to be in one industry. There is a gating process. Which technology should be used? There should be a decision maker,
Yes, sir.
so who has an understanding. So I used to do that, screen all the different technologies and use the best one. We did a pilot plant study for a coal mine
Okay. Yes,
where
sir.
we put a pilot plant for three different biological systems, and then we treated the wastewater coming out of the coal mine, and then we did an analysis which is the best technology we should go for removing selenium, right? Similarly, selenium is one of the component in the coal
Yes, sir.
mine, is
Yes.
it? So then we selected one technology, that is a gating process. That is the expert like you or many people here, you will have to apply which is the best technology, how efficient it is. That is why we do a laboratory study, pilot plant, and then big plant. So
Yes.
this is how it is done, and it is for experts, like you guys to decide which is the best one, not the sum, right? That is how.
Thank you, sir.
Thank
Good afternoon, sir. Sir, as you have mentioned the phosphorus removal step,
you.
is there any additional steps industries are taking to remove the phosphorus as it is a limiting factor in fresh water?
Yes, there are many technologies where even in the domestic wastewater removal, where the phosphorus biological processes are there where they can remove phosphorus. But if your effluent has a more phosphorus, you are discharging it to the river, it may give rise to algae, correct? Uh, all right. So if it is so, then the algae growth and all that freshwater will come into risk. right? So there are technology available for those kind of pollutants existing in the waste.
Sir, after the treatment, can we use these treated liquid effluents as a organic liquid fertilizers?
Organic liquid fertilizers, people apply, in the sense, if large effluent is produced, you can use that as an for the irrigation. Then you will have to have a monitoring of the effluent, type of the crop you are growing, is it, how much you are applying, that all is important, right? So it should be contaminant free, it should be work as a nutrient which are present in that nitrate. The wastewater which is treated has a nitrate in it to the certain level, can be applied for the land, and the nitrate uptake we study in the crop, and also how much remains in the soil. I have one example case study here I will mention you. We apply the treated wastewater, industrial wastewater, to the growing grapes. That grapes again is used to make wine, is it? So then in that case you should have a soil monitoring, should have a crop uptake, how much is taken by the crop and how much is in the soil, which is not creating any issues with the groundwater and the soil, right?
Sir, my question is related to greenhouse gas. So, as we know that wastewater treatment is an energy intensive process, so which directly you can say that it emits CO2 because it comes from coal mostly. And then during the nitrification process, that is during the treatment, biological treatment, nitrification, denitrification, there is emission of nitrous oxide during the process, and also anaerobic, during the anaerobic process there is methane emissions, so which are two important greenhouse gases. So how significant is greenhouse gas emissions when it comes to wastewater treatment?
Yeah, we have there is a greenhouse gas emission also. uh, Greenhouse gas emissions is the carbon inventory, we study carbon footprint, right? So it depends upon, in the wastewater also produce certain greenhouse gas, right? So we quantify that, how much is the contribution greenhouse gas is or produced, and that is inevitable. Greenhouse gas is another level of work. We can also discuss more about that. Uh, we have a lot of work has been done in the greenhouse gases, right?
Okay, so sir, do the industry are they also concerned about the this greenhouse part or not?
They are concerned, like water. I will take 2 3 minutes. So you see how the water use has come. Similarly, a greenhouse gas emission quantification is there for the industry. Each industry have to quantify, that is called a carbon tax, is it? Carbon tax, they have, if they are producing this much greenhouse gas, then they have to pay. So to go in little bit more, I worked in the industry. I was worked with the state government, federal government, and in when I was in Canada, to develop the baseline study for a greenhouse gas. What we did is, each coal mine, how much greenhouse gas it contributes. Accordingly, government put a tax per ton. You will have to pay $15, right? So they gave 100 ton free in the beginning. Then for every above 100 you have to pay. So they started collecting millions of dollars, and today also it is going on. So each industry, how you do the income tax, in the similar way, industry has to do a carbon audit, right? So they do how much carbon they are contributing, and accordingly they will have to do. We started in 2010. It started in Canada. I was working at that time in the Canada for coal industry. We work with the state government and federal government in developing the baseline study. And for 3 years back, we will go and develop the baseline study. What was the greenhouse gas produced this year, this year, this year? That is taken as a base, and then above that 100 they will have to pay money. That way they collected millions of dollars, and then it is regulated. In the greenhouse gas, there are coal mine which produces, there is an emission factor, how much you are producing the coal, based on that it is converted into the greenhouse gas, carbon footprint, and they will have to. So that is also coming up next stage. It is already there in other countries. We do regular basis. Oh, I can tell you more detail about that, how we developed a greenhouse gas baseline study, how we did the carbon uh, calculations. You can also go back. We developed a system. If you put the production, you will find out how much is the greenhouse gas produced per day. So that is the system.
Good afternoon, sir.
Okay.
Sir, as I'm from agribusiness management background, so my question is, my interest always comes into the collaboration and partnership. So
Okay.
yesterday we had a lecture on lecture number 4, small and medium industries. So what is the scope of public and private partnership? Like in India, we have a Namami Gange
Hmm.
that launched under the Ministry of Jal Shakti in 2014. So what are the initiate? Is there any scope for the public and partnership?
Yes, in today's world, there is a large scope for a public partnership, public and government
Public
sponsorship.
and private.
Yeah, that is how the most of the roads and infrastructures are developed. Private companies, they put money and invest, they collect the tolls, and after 20 years it can be made free. That is how it is done. That is a very uh, build, operate, and transfer. You will build the system, operate it for certain years, and you will also take a lot of incentives for that, and then transfer to the government. So that system is working very well. It is not necessary that everything has to be done by the government, right? Many public partnership is going in a very wide way, and it is most popular today. Yeah, in especially in India, a lot of work is going on, and a lot of roads, tunnels. Yeah, in UK, you will also find big sewage treatment plants are built and operated by a private people. We have that system already in United States. They build a big treatment plant system, and they accept wastewater from different industry. They charge them. This is the cost. We'll treat and we'll take care of wastewater. That is already there.
So, sir, what are the initiative taken by the already taken by the USA? Any example?
There are
So that can
many. There is that in the cities where I go. That is why I said this is the publicly owned treatment plants. This is also, there are cities where industries or group of people will come together and build a treatment plant. We have also given authorization. They can collect
yeah, that authorization is there.
based on the volume of the wastewater. They can, just like an industry they do. Yeah, there are many. There are many like that. It is
Thank you,
not
sir.
necessary. It is
Thank you.
should be done by the government. Very good.
Thank
I
you, sir.
think you don't have questions.
Yeah,
We'll
we have
just
to
do
stop
that,
this.
but don't forget to write a half page about yourself, what you learned, right?
So next day, come with that note. Okay. So bus is waiting for you, and you should go and take a